Hello friends, my name is Peter. In this episode we will apply both kinematic principles and Newton's laws of motion to understand and explain the motion of objects moving in two dimensions. The most common example of an object that is moving in two dimensions is a projectile. Today, we will talk about projectile motion. Let us first define what a projectile is. A projectile is an object upon which the only force acting is gravity. There are a variety of examples of projectiles and I will explain you more of it in the next slides. An object dropped from rest is a projectile provided that the influence of air resistance is negligible. An object that is thrown vertically upward is also a projectile provided that the influence of air resistance is negligible. And an object which is thrown upward at an angle to the horizontal is also a projectile provided that the influence of air resistance is negligible. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity. A motion that moves both horizontal and vertical motion is called projectile motion. This type of motion involves object that is thrown or launched into the air. Imagine a cannonball being fired at some angle from the horizontal. It will travel some distance up into the air before eventually falling back down and hitting the ground some distance away from the cannon. We can use a parabola to represent the path of this object. Here is the graphical representation of the parabolic shape. The important thing to understand about these kinds of examples is that the horizontal and vertical motion of the cannonball are completely independent of one another. To derive this idea home, consider two marbles, one dropped from a particular height and another that rolls off of a surface at that same height with some horizontal velocity. If these begin falling at the same time, they will strike the ground at the same instant because their vertical motion is independent of any horizontal motion. The one with horizontal velocity will cover some distance in the x direction, but it will all downward at the same rate as the one that falls straight down, and so they will have identical air times. How can we apply this to other real-world examples? Since I am a professional gold medalist champion as a football player, let's kick this football so I can explain it to you further. This time, let's kick a ball at an upward angle of 30 degrees of the horizontal from the very edge of our favorite 100-meter cliff and with an initial velocity of 8.5 meters per second. Again, we will ask how long before the rock hits the ground. And now additionally, we want to know how far away from the edge of the cliff it will land. Before we move on to solving problems, first things first, let's make sure we understand how these questions relate to motion in both the x and y direction. In another case, the distance it travels from the edge of the cliff depends on the horizontal velocity but also the time it spends in the air, because once it hits the ground it can't travel any further. And the velocity at any moment can also be split into components. The horizontal velocity will be the same at every moment in this trajectory as long as we disregard wind resistance. But the vertical velocity will be the greatest at the moment the ball is kicked, then decrease until it reaches zero at the zenith, and then become increasingly negative until it hits the ground. This is because there is a constant acceleration in the negative direction due to gravity. These are the important equations of projectile motion needed to answer these questions. Now let's test our skills by sample problem. A football is kicked at an angle of 30 degrees traveling at a speed 40 meters per second. Find the maximum height that the ball will reach. By using this equation, we are able to find that the maximum height of the ball will reach is about 20 meters. Now next up is, we are looking for the horizontal distance or range traveled by the ball. By using this equation, we are able to find that the range of the ball will reach is about 141 meters. And for the last question, at what time the football will take the ground? By using this equation, we are able to find that at time of 4.1 second, the ball already landed on its position. Thank you so much for listening. See you again.